First of all, I would like to thank Milan Jyoti for inviting me over here and for putting together this conference. And if it was not for him, I will not be here. And I would also like to thank all of you. If all of you did not come, then again I will not be here. So I'm very happy to be this beautiful resort city of BANSKO. It's very, very nice. It is a very special treat for me and my wife, who is also here for this conference. So today I have both good news and a bad news for you. First, the good news. Good news is that anything and everything that I have to say about my presentation, I can summarize in one sentence for you. And that one sentence is that whether you talk about cancer, or you talk about diabetes, or you talk about Alzheimer, or you talk about cardiovascular diseases, or any of that chronic diseases, what my experience has been that inflammation plays a very, very, very important role. And if you were to control that inflammation by using polyphenols, and that's what this conference is all about, that if you were to use these polyphenols, you can control, you can prevent, you can treat various chronic diseases. So that is essentially a good news that can be summarized in one sentence. But the bad news is that I have 150 slides to go through. So, and that is all to justify that one statement that I just made it to you, that what it is all about. I tried very hard to cut it down, and I got up 3 o'clock this morning, where I brought from 200 slides down to 150. So that's still enough. So having said that, let's kind of get started. And just to begin with, I think I have a little food for thought. And it's very, very important for all of us to think, because we are living in an era of genomic and proteomic and metabolomics and so forth. And it is very important for us to realize that human body is made up of 13 trillion cells, and each cell contains 24,000 different genes. And the human brain contains nearly 100 billion neurons of at least 1,000 different varieties. And these nerve cells make at least 100 trillion connections. Just like no two human beings are alike, no two cells are alike, and no two genes are alike. All chronic diseases are mediated through dysregulation of multiple genes. Therefore, if so, how do we expect to have a cure to any disease by targeting a single gene? And that's what drug industry is trying to do, that they're targeting one gene at a time. And it is a total desperate situation that it's not working. And that's where polyphenols have a very special opportunity. And that's where I'm going to try to convince you that the way the drug industry is going is not the way to go about it. And as Milan mentioned, that I come from the US, and I don't believe that there is any country in the world that has spent more money trying to find a cure to cancer or diabetes or Alzheimer or any of the chronic diseases than the United States has. Yet, the irony of the situation is no country has more cancer than the United States. No country has more diabetes than the United States. No country has more obesity than the United States. No country has more Alzheimer than the United States. And this is one of the global scan is there to tell you. And so as if that's not enough, what the future holds, that cancer is going to double with the next 20 years. And here is the new cases of cancer in 2002, 10 million and 7 million deaths. Here is 2020, that here you can see 15 million new cases and 10 million deaths. And here is 2030, 20 million. And it turned out that most of this doubling is going to come from countries like India and China. Why? Because all those countries are trying to be highly Americanized. So therefore, they are heading in the same direction in having the maximum amount of cancer. So as I mentioned through all this, has been our working hypothesis that dysregulated chronic inflammation caused by lifestyle factor, and everything is about lifestyle, mediates chronic diseases including cancer. Here is a cover issue of Science that some of you may have seen it, and it is all about inflammation, and this is January 2013. And here you can see that several age-related chronic diseases such as metabolic syndrome, cardiovascular diseases, neurodegenerative diseases have an inflammatory component. And here is, in that same issue, neutralizing tumor-promoting chronic inflammation, a magic bullet. I highly recommend you to read up on that. We have our own monograph, and this is all devoted to inflammation, lifestyle, chronic diseases at silent name. And here is a cover of Immunology, which is one of the most prestigious journals. And as you can see on the cover of this one, there are flames. Everything is flames. And these flames are caused by what is called cytokines. And these are the molecules that are produced by the cell. So we happen to discover a molecule that's actually responsible for causing these flames. And we discovered it as an anti-cancer agent, and this molecule is called tumor necrosis factor. We are the one who named it TNF alpha, TNF beta. We were the first one to purify, sequence, and clone. And as you can see from this article, signaling pathways of the TNF superfamily, a double-edged sword. When I say double-edged, it means that if these flames remain where they belong, they are therapeutic. However, when the same flame gets out of control, it causes all the diseases. And here is another review that we did more recently, historical perspectives on the TNF and its superfamily, 25 years later, a golden journey. And the golden journey has a double meaning. It does not mean 25 years, but it is also means a yellow curry powder that I'm going to tell you about, which can control these flames. And here some of you again may have seen this, a cover of Time magazine, that the secret killer. Again, it is all about inflammation and its connection with heart attack, cancer, and various other chronic diseases. And depending on where the fires are burning, it has a different consequences. So here is a controlled fire. You have a fire burning in the kitchen. You can turn the stove on and make your tea and coffee. Here is a fire burning in the living room. Here is in the bedroom. And it is a very controlled fires. But same fires, when get out of control, that's what you get. So it is these fires, so fires are not bad, but it is only when fires get out of control, and that is when it causes havoc. And so that's where the inflame that it comes from. So where these fires are coming from, here you have a lifestyle factors. Here is you can see cigarette smoking, radiation, alcohol, and here is a diet, obesity. They are all pro-inflammatory conditions. And here is the environment of pollutants, industrial pollutant, diesel, acid rain, grilled food, fried food, red meat. Virtually all the bacteria that have been linked with cancer turn on inflammation. Virtually all the viruses, without exception, turn on inflammation. Cigarette smoke, psychological stress, mechanical stress, chemical stress, any kind of stress. Even chemotherapy and radiation, that is meant to treat cancer is actually turning on inflammation, and the patient is feeling miserable not because of the cancer itself, but because of the treatment. And here is ultraviolet radiation, here is alcoholic beverages, they are all turning on inflammation. So cancer is a preventable disease that requires a major change in lifestyle, and it turned out that 30% of all cancers are due to tobacco, 35% are diet, and 14 to 20% obesity, 18% radiation, 7% environmental pollution, and here only 5 to 10% due to genes. 90 to 95% of the cancers are preventable. And genes, there's nothing that you can do about it, yet all the money from NIH is going into trying to fix these genes. And it has not happened, it is not going to happen, but that's where all the resources are going into. So here was this gentleman, his name is Rudolf Virchow from Germany, 19th century Germany, and he is the one who was the first one to define inflammation as a redness, swelling, heat, and pain. And he was the one linked inflammation with atherosclerosis, rheumatoid arthritis, multiple sclerosis, cancer, Alzheimer's, you name it. And he also introduced the word for inflammation called ETs. Somebody says you have arthritis. All they're talking about inflammation of the joints. Doctor says you have a bronchitis, inflammation of the bronchus. So wherever this word ETs appears, it all means inflammation of the various organs. And now as of today, there are 200 different kinds of ETs. Doctor says you have myocarditis, means inflammation of the heart. Cervicitis, inflammation of the cervix. So these are all different kind of inflammation that are out there, and it is nearly 43% of the patients who have inflammation of the colon. They will develop colorectal cancer after 25 to 35 years. So it does not happen overnight. You can see the amount of time it takes to develop colorectal cancer, and it proceeds with inflammation. So here, for example, in Japan, that it is a 7.9 cases of colitis out of 100,000. India is 44.3. US is taking the lead over here, is 229 per 100,000. So one of the highest amount of colitis, again indicating that it is a very pro-inflammatory lifestyle. And here, as you can see, that all the various factors that I mentioned you earlier, they lead to inflammation, that lead to different kind of ETs, and that leads to lung cancer, liver cancer, cervical cancer, you name it, that again indicating inflammation precedes virtually every cancer that is out there. So if you can stop the inflammation at early stage, you can stop most of the cancers. Even a bone loss is turning out that very much linked to, again, inflammation. So how do we define this inflammation at the molecular level? It turned out that there is a transcription factor called NF-kappa B. It is a master switch as you walk in, that you can turn on this switch, and this NF-kappa B activation is a major mediator of inflammation in most chronic diseases, including cancer, and if you were to inhibit NF-kappa B, you can prevent them and delay the onset of the chronic disease. So as of today, there are 500 different genes that have been identified that are regulated by NF-kappa B. And here are all those 500 genes. So typically a drug industry will target one gene at a time, and it simply doesn't work because there are so many bypass mechanisms. So here, as I mentioned, that this is the molecule that we happen to discover. This is TNF. It leads to activation of NF-kappa B. This NF-kappa B leads to the activation of TNF, which lead to IL-6, that lead to STAT3. This NF-kappa B has been linked with the survival of the tumor, chemo resistance, radio resistance, proliferation, angiogenesis, invasion metastasis, and bone loss. And I'm going to show you the proof of the concept that by blocking NF-kappa B, you can inhibit all these various processes. So here are, for example, if you are sitting over here, hopefully you are in a resting stage. So your NF-kappa B is not active. However, here in all these different tumors, whether they're tobacco-linked cancer, carcinogen-induced cancers, virus-induced cancer, UV-induced cancer, in all those cancers, NF-kappa B is active. And it is doing the damage. And this NF-kappa B is now, here are the various genes that are involved in the transformation. It is involved in the survival of the tumor, involved in the proliferation, invasion, angiogenesis, and metastasis. Here it takes 10 to 20 years to go from here to here, another 10 years to go from here to here. In other words, this inflammation in most cases starts at the age of 20 and it becomes cancerous at the age of around 50. So total 30 years of inflammation, and that is what is causing the damage. And this inflammation is NF-kappa B is a very important part of the immune system. So without inflammation, you don't have an immune system. Without NF-kappa B, you don't have an immune system. So you need the immune system to protect you, but that is very controlled inflammation. However, it is same inflammation, but it gets out of control. It has been linked to all these various diseases. And even something like aging. Nobody considers aging as a disease, but as we get older, NF-kappa B comes up, and that's the time various chronic diseases take over. And there is already proof of the concept that there is a polyphenol that inhibit NF-kappa B that can slow down the aging process. So bottom line through all this is NF-kappa B is enemy within us. It can be a friend if it remains in the immune system, but it becomes a foe moment it gets out of the immune system. So NF-kappa B cancer is a matter of life and death, and that's what we need to stop. So here you have a stress, you have NF-kappa B, you have inflammation, you have cancer. Either you get rid of stress altogether, which is sometimes not possible, because as long as we are living, we will have a certain amount of stress, we will be exposed to certain type of insults, or we find the ways to control NF-kappa. So what we really need is a fire extinguisher, okay? And that is how to suppress NF-kappa B activation, and here I underline the word safely. And what I mean by that pharmaceutical industry realizes NF-kappa B is a very important target, and they have come up with a lot of inhibitors, but they are not very safe. So safety comes a number one issue. So we are living in an era of genomics, as I mentioned earlier, that here is a cancer genome landscape. So people have gone cancer by cancer and found out that what kind of genes or cell signaling pathways that has gone wrong in cancer. And here is a review that appeared in Science, where they found that the total 140 genes that drive virtually all the cancers. And if you can control this 140 genes, you can virtually control most of the cancers. And then there are other genes that are passenger genes that are not actually driving the cancer, but they are also playing a role. And there are total 12 cell signaling pathways that are playing a role in virtually all the cancers. And I'm going to show you that this polyphenol will control most of those cell signaling pathways. And here are cancer by cancer that they have gone and what kind of mutations are occurring on different cancers. And here are a number of genes that are indicated again in the same review, that how many genes are altered, that in any given cancer, that it is all outlined, and drug industry simply does not know that how to control all those genes by using a single drug. So here are the various pathways that are outlined and that are involved, whether in the survival or cell fate and so forth. And again, polyphenol, we can control all of these pathways without exception. So, and then eventually that if they use one inhibitor, that very soon the tumor develops resistance within a matter of days and weeks, and therefore that they have to come up with some other drug. So if you start out with a drug that is a multi-targeted, that is what is really required. And here are some of the examples of the mono-targeted drugs. Here, for example, there is Avastin that gives a total 0.3 month increase in lifespan and cost you $1.3 million. Here is another drug, which is an EGF receptor inhibitor. Again, 0.3 month increase in lifespan. And here you can see for yourself $600,000. Who can afford that kind of money? So question here, that article that appeared, biological targeted cancer therapies and marginal benefits. So you can see that these are the wonders of the modern medicine, and that's not going to help anybody. And here are some of the monthly costs. Another article just appeared this month that how much is the monthly cost if somebody has a cancer and using these targeted therapies. And you can see for yourself that this is a futile exercise, but this is a total desperation, and that's what the industry is at. So solutions are very, very simple. Sometimes one pays most of the things one gets for nothing. And Sloan School of Management at MIT and Harvard Business School has created what we call farmers market. What we really need is a farmers market. And that's what it really comes down to. And this is what I mean by farmers market. So here you have a fruits, you have spice and condiment, you have a vegetable, you have a cereals. And what I'm going to show you that all these can block NF-kappa B. All this can block most of the pathways that I just showed. And here there are 215 different kinds of fruits out there. And this is coming from our book. And here is 95 different kinds of vegetables, 30 different kinds of pulses, 11 different kinds of nuts, 11 different kinds of cereals. We need to make use of. And here is 108 different kinds of spices. So it is believed there are 800 different kinds of foods out there, and average American eats no more than 10. So variety is the name of the game. So we have a book called Healing Spices. Again, if anybody is interested, can look it up and talks about all different spices. Another one, we have a molecular targets and therapeutic uses of spices, that what is in there that is responsible. Another one that just came out last week, Trends in Pharmacological Sciences, teaching old drugs new tricks, cancer drug discovery by repurposing, teaching new tricks to old drugs. So this is where traditional medicine has been around for thousands of years, and that can hit all the targets that what I just talked about. And here is a Science has a whole cover issue, and you can see September 21st, 2012, and what they are talking about. And all these things can be used to target all the cell signaling pathways that I just mentioned, and this is nothing new. And here is a Hippocrates mentioned almost 25 centuries ago. Let food be thy medicine, and medicine be thy food. And that's all what we're talking about. So this is what we identified in our group, that these are all the different spices that we identified that can block NF-kappa B. Here are various Ayurvedic medicine that has been around for thousands of years that we showed blocks NF-kappa B. Here are different fruits and vegetables. Here are traditional Chinese medicine, and here are some of the others. They are beautiful blockers of NF-kappa B. And here, for example, cashews. You eat some cashew, it's not going to hurt you. And here we have provided the proof of the concept that here are the what is present in cashews and various other those plants that what I mentioned in the previous slides. So we know exactly what is there in that plant and how it blocks NF-kappa B and where it binds in the pathway. So here is all the different phytochemicals that we have identified. But we have to remember that here is David Newman from the National Cancer Institute, natural product as sources of new drugs over 30 years from 1980 to 2010. Natural products have played a significant role in the discovery of cancer drugs over years. More than 70% of drugs have their roots in natural products. And that's again what we're talking. When solution is simple, God is answer. Again, it's Albert Einstein. Now there is a whole branch, and part of the reason I'm over here because on Wednesday I'm giving another talk. There is a whole new science that has come up called integrative oncology. And here is Donald Abraham from University of California, San Francisco, which is basically using all these various plants that what I just described to you, along with the currently available drugs, and see how we can boost the standard and where we can switch to the natural products. So natural products remain quite interesting and often represent the most exquisite example of targeted therapies selected for their activity through evolution. And that's what we are talking about here. So, and even MD Anderson, which is the biggest cancer center, we see about 2,000 cancer patients every day, reduce your risk of cancer by 30 to 40% by adapting healthier eating habits. So one of the compounds that I want to talk to you about is tocotrienol. This is the vitamin E. Most of the people know tocopherol, but very few people know tocotrienol. And if you look at the tocotrienol versus tocopherol, the tocopherol, there are 3 double bonds that are present in tocotrienol, which are completely absent in tocopherol. And so there is a very little, there are only 32,000 publications of tocopherol, only 749 for tocopherol. So very little known about it. All the clinical trials have been done with this, nothing is known about it. And here, this is where it comes from the various plants. And here are further the amounts that are present in those various plants. And here, just to show you that it is a gamma tocotrienol, but not tocopherol, that is inhibiting NF-kappa B. And here we indicated the mechanism through which it does that, leading to suppression of anti-apoptotic genes and potential for apoptosis. And here is the NF-kappa B that is examined by DNA binding. And here you have tocopherol, it has no effect at all. And here you are tocotrienol, we completely wipe it out. So because that it can inhibit NF-kappa B, we examine its effect against pancreatic cancer. As all of you know, pancreatic cancer is one of the most lethal cancer. And here are some of the legends who died of pancreatic cancer. That you can very well imagine that obviously they are looking for something, obviously they did not find it. And so here we published that gamma tocotrienol inhibits pancreatic tumor and sensitizes them to gemcitabine. And gemcitabine is the best treatment that is available for this particular tumor by modulating the inflammatory microenvironment. And so here is another one that come from neem plant, and here is the neem plant, which is very, very common in certain parts of the world. The active compound is called nimbolite. And so this is the active compound, and here we showed that this particular compound again binds to the cysteine 179 of the kinase, which causes NF-kappa B activation. And further, it synergizes with chemotherapeutic agents. Here is another paper that we published on the same compound where it, in vivo, we could inhibit colorectal cancer growth by using nimbolite again by blocking the inflammatory environment. Here is another compound that we identified from the same plant called azidaron, and apparently it induces death receptors and leads to the death of the cancer cells. And here is another compound that we identified, and this comes from guava fruit, and it is called maureen, and it blocks the STAT3 pathway. And the remaining few minutes I have, I would like to add, talk about some spices, that what I call add spice to your life. And here is, as you know, that almost 500 years ago, that Vasco da Gama and Christopher Columbus, they both were looking for spices. And here is Christopher Vasco da Gama, and way back in 1498. The route that he used is called spice route. And what kind of spices he was looking for? These are all the various spices out there. And so here apparently you can see that this article appeared in Cell, from exotic spice to modern drugs. The global demand for more affordable therapeutic and concern about the side effects of commonly used drugs are refocusing interest on Eastern traditional medicine, particularly those from India and China. So this is what we are talking about, targeting inflammation-induced obesity and even metabolic diseases by curcumin and other nutraceuticals. And if you look at this curcumin, which is coming from turmeric, that here is, you can see the structure homology. That here is a cinnamic acid, comes from cinnamon. Here is a piperine that you can see, this is a black pepper. And here is a ginger that you can see the structure homology. Here is a cloves, again you can see the structure homology. And here is a licorice, you can see the structure homology. And here is a red chili. You can see that how similar some of these compounds are. And all these compounds block NF-kappa B without exception. And here we looked at all the various targets for obesity, and you can see they are inhibited by curcumin. And similarly here, you can see that for diabetes, that it will inhibit. So here is a curcumin coming from turmeric, blocks NF-kappa B. And here is a fennel, here is a red chili, here is a fenugreek, here is a holy basil, here is a cloves, and here is a fennel again. Red chili blocks NF-kappa B. We published quite quite actively, and here is the NF-kappa B, and here is the STAT3 pathway, both are inhibited. Here is a ginger, that it will inhibit NF-kappa B, doesn't matter what the activator is, and bone loss. Again, NF-kappa B, as I mentioned, plays a very important role in bone loss, and with breast cancer, you see that bone loss and ginger compound. Here is a black cumin. Again, we showed that it blocks NF-kappa B, and then here is the inhibition of tumor growth that we showed in the animals it blocks. Here is a fenugreek, blocks NF-kappa B, and here is a fennel, blocks NF-kappa B. Here is a black pepper that we showed that it blocks NF-kappa B. Here is a paper that appeared from Harvard group in Nature that 2 years ago, where they screened 450,000 compounds. And at the end of the day, they came up with only one compound that was 10 times more potent than even paclitaxel. And it comes from a long pepper, and called Piper longum. And here you can see the structure of this compound. And again, you can see the title, Selective Killing of Cancer by Small Molecule Targeting Stress Response to Hormones. And again, we showed that that also is working through NF-kappa B. And here is a cardamom, which is a black cardamom, and we showed that it is quite effective in inducing death receptors and inducing death of the cancer cell. And rank ligand, which is causes the bone loss, the antibody against rank ligand, have been approved by the FDA. And apparently, we showed that cardamom will work quite effectively in inhibiting bone loss induced by rank ligand. So much so that that Scientific American is declared us as a spice healers, because we use different kinds of spices to treat this disease. So I think that the last few minutes I would like to spend on curcumin, the one that we know the most about. And apparently we are on this cover of Trends in Pharmacological Sciences, and this is what the turmeric compound, which is a yellow curry powder that curcumin looks like. And so pharmacological basis for the role of curcumin in chronic disease, age-old spice with modern targets. And it was this gentleman, Vogel, way back in 1842, was the first one who isolated this compound. And this gentleman actually determined the structure, and this one synthesized it. And this is what the structure looks like. The first paper ever to be published on this compound was in Nature, 1949. That indicating it is antibacterial agent. And here are the number of publications over the years, and this is, there were only 50 publications when we got into it. As of today, there are 6,000 publications on this particular compound. As I mentioned, that this was the first paper as an antibacterial agent. And this is what the plant looks like, and this is the structure, and it is a rhizome, that's where it comes from. And here you can see that if you take this much turmeric, you get only this much curcumin, and this is curcumin-free turmeric. And under alkaline condition, this turns red, and curcumin is metabolized in the body, and it turns white as it looks over here. So here is the first paper that we published that curcumin inhibits NF-kappa B way back in 1995. And here are most of the cancer-causing genes. We showed that curcumin will down-modulate it. So as of today, to my knowledge, nobody has found a cancer that curcumin will not inhibit. And here I have outlined for you that virtually all these cancers are inhibited by curcumin. And there is a proteasome pathway, and here is the curcumin bind to various proteins in the proteasome pathway and inhibits it, and here are various other proteins that are affected by curcumin. You can see the list is very, very huge. The degradation of all these proteins is inhibited, and here are all the various inflammatory targets of curcumin that it will inhibit. So far, I have not found a pro-inflammatory target that is not inhibited by curcumin. And so here is that curcumin has also been used for colorectal cancer, and there are multiple targets again for colorectal cancer, and curcumin will inhibit most of those targets. And there is a miRNA that is involved in inflammation, and these are all the miRNA that has been linked with inflammation, and here you can see that curcumin will inhibit most of those miRNA. So curcumin is also a chemosensitizer, and it can be, so it is used as a chemosensitizer and a radiosensitizer for the tumor. As I mentioned, both chemotherapy and radiation activate NF-kappa B, and curcumin will inhibit that NF-kappa B and sensitize, act as a sensitizer, but it's a chemoprotector and a radioprotector for the normal organs. So you can imagine it is absolutely ideal situation. Here, for example, you have a paclitaxel, and this is looking at the breast cancer metastasis to the lung. And here you have a curcumin, and here you have a curcumin plus paclitaxel. That it is a very, very synergistic. So cancer treatment requires suppression of multiple cell signaling pathways, and here are all the various pathways. And that's what I'm talking about, multi-targeting. So the drug industry will use here one target at a time. Curcumin will inhibit all of them, plus here are the additional targets. So just to give you that some idea, because a lot of things work in cell culture, a lot of things work in animal, question is what works in human. And that's why we are doing a drug development. And so here there are a lot of clinical trials have been done with curcumin. As of today, there are more than 65 clinical trials done with curcumin, which included more than 1,000 patients have been completed, and as many as 35 clinical trials are on. And here is between 37 and 1995 trial. Here is a 91 to 2010 trial, and here are 52 trials between this period. So here you can see that all the different diseases, and these are all pro-inflammatory diseases where curcumin has been tested. And so here is the first trial that was published in 1937. You can imagine in Lancet. And this trial refers back to 1748 trial. So you can imagine how back this literature goes. So a lot of people think that curcumin bioavailability is a problem. My question is, how big is the problem? Here curcumin has been labeled, and this is its appearance in the blood in 2 minutes, 20 minutes, 60 minutes, 120 minutes. Here is in a thyroid, heart, lung, liver, spleen, kidney, muscle, brain. It is everywhere. No problem at all. This is just a regular curcumin. There are a lot of companies have been making different kind of formulations. And here is another trial where the F18 labeled curcumin was used, and you can see that it's appearing as early as 2 minutes. And curcumin is fluorescent, and one can very quickly see it. And here is they used piperine, which inhibits the metabolism of curcumin, and then did the same thing. And you can see that it is there. This is a trial that came out of Harvard, that where the curcumin bind to amyloid protein. So it prevents the aggregation of amyloid, which is involved in Alzheimer's. And here they could show within 30 minutes that curcumin being fluorescent, it is binding to the amyloid. And here is a gradual disappearance, 60 minutes, 120, 240 minutes. So it is no problem at all. And so there is a company called Idina, and they have made this curcumin, which they conjugated with phosphatidylcholine and called Mariva. And here you can see that they published that this is a regular curcumin, and so this is a regular curcumin, and this is Mariva. You can see Mariva is disappearing a lot more rapidly than the regular curcumin. So you can decide that what one should be taking. And again, if you curcumin combined with yogurt, it forms a nanoparticle. There are actually proteins in curcumin, in yogurt, called lactoglobulin and casein. Both actually physically bind to curcumin and forms nanoparticles. So that can be potentially another delivery system. And here, as you can see, they're all physical binders of curcumin. They are huge. No wonder that curcumin is not easily bioavailable. Why? Because there are so many proteins binding to curcumin. So, and the affinity can be anywhere from picomolar range to millimolar range. And with GSK3 beta, which is a lithium, is the best known inhibitor, and is used for schizophrenia, and curcumin bind to GSK3 beta in a picomolar range. So here are some of the clinical trials with curcumin, and as you can see that this is came out of University of Leicester for colorectal cancer, and here is one of the biomarker glutathione as transferase, and this is pre-curcumin, and this is post. 15 patients, and you can see as little as 36 milligram per day. It is effective in down-modulating this particular enzyme. Here is another clinical trial that came out of Johns Hopkins, and here is only 5 patients, 40 milligram per day, and you can see polyp numbers are down, polyp size is down. Here is another clinical trial where they looked at the recurrence of the tumors, and if they did not give curcumin, there is 8 out of 39 patients had a recurrence of the tumor. If they gave curcumin within 6 months, only 2 out of 43 had a recurrence of the tumor. So here is a colorectal neoplasia. Again, this trial came out of Chicago, where they gave 2 gram and 4 gram, and here you can see 4 gram is quite effective against aberrant crypt foci. Here is a tropical pancreatitis. You can see malondialdehyde is down, glutathione is up, and here they used, here you can see 1500 milligrams. Here is another clinical trial of prostate cancer where they looked at the PSA level. This is less than 10, this is greater than 10, and they could down-modulate PSA with as little as 100 milligram per day. Here is another clinical trial where they used it for oral submucous fibrosis, and 3-month trial, 58 patients, and most of the patients responded. Here is another clinical trial where they looked at the urinary mutagen in smokers, and again they used a whole turmeric, 1.5 gram per day for 30 days, and they could down-modulate all the smokers. This is a clinical trial that came out of China, 126 patients, 360 milligrams 3 times a day. Loss of body weight is reversed within 10 to 20 days, and the TNF is down-modulated, apoptosis is upregulated, and you can see P53 is upregulated. Here the BCL2 is down-regulated, BACC is upregulated. So this is a clinical trial that we did in MD Anderson, where we looked at the multiple myeloma patients, and we could show that the inhibition of NF-kappa B in this patient. This is another clinical trial we did with the pancreatic cancer. Again, we could show that it works quite effectively. Here you can see this is the tumor, and this is the disappearance of the pancreatic tumor in these patients, and some of the patients respond a lot better than others. So even arthritis, that TNF blockers have been approved for arthritis, and there are a number of clinical trials. And here you can see active rheumatoid arthritis, 45 patients, 8-week trial, 500 milligram, and C-reactive protein is down. And here is another clinical trial with C-reactive protein, osteoarthritis. You can see it is down-modulated. Here is another osteoarthritis trial with 100 patients. And you can see all the biomarkers with as little as 200 milligram per day. It is down. And psoriasis is another one that where TNF blocker have been approved by the FDA. And here you can see this is a topical application of curcumin. And this is before and this is after. You can see psoriatic lesion disappear. Now it is being used for acne keratosis, acne wart, dermatitis, eczema, wound healing, sunburn, and skin cancer. And here is a uveitis, another clinical trial that appeared 106 patients, 80% of the patients responded. And here you can see the biomarkers of the disease that are down-modulated again with uveitis. And there is some trial with the heart, and here is the hypertrophy of the heart that within curcumin within 2 weeks that curcumin can inhibit hypertrophy of the heart. And here is the serum peroxide and the cholesterol level, HDL is up, and serum peroxide, malondialdehyde is down. And diabetes trial there have been also been carried out, and the one of the first trial done with the diabetes blood sugar level, just giving a curcumin, it is down-modulates it. And here is a randomized parallel group placebo-controlled trial for 8 weeks that where they compared the curcumin with atorvastatin, and they examined endothelin-1, IL-6, TNF, malondialdehyde. You can see with curcumin, 150 milligrams twice a day. All of them are down. And here it shows you the number of patients that they examined. So it is this kind of the proof of the concept. Here is a type 2 diabetes trial that just came out of Thailand, and where they used 240 patients. And you can see that 1500 milligram curcumin, and if they did not use this curcumin, 22 out of 120 patients, they had a diabetes. If they use curcumin, only 0 out of 122. 20 came down with diabetes. So it is this kind of the proof of the concept that curcumin is doing what it is supposed to. And here is a type 2 diabetes nephropathy again that found some positive results. Here is a hepatotoxicity. Again, I'm kind of quickly going through it to give you an idea. And so this is just a slide to show you. This is come from the NCI, the Department of Nutrition. What they put together, that here is an incidence of cancer in countries like India where a lot of the spices are consumed, and here is a cancer in male versus female. And here countries like United States where the spices are not consumed, and you can see that the incidence of cancer in male versus female. So I think that it is this kind of, and here further the data that is out there that US, the incidence versus death. So, and here is India, you can see for yourself. And these numbers are changing very, very rapidly. As I said, that as India is getting more and more westernized, that there is more and more cancer is appearing. With that, I stop right here and thank all of you for your attention.
I noted that you stressed the polyphenols. In all those events, you have other secondary metabolites. Could you comment on that?
You mean other cellular metabolites?
Like isopropyl,
curcumin,
calories, not necessarily curcumin.
Yeah. So I think curcumin is one of the compounds we have studied the most, and other people have studied the most. And all I can tell you, more we study, more we feel lesser we know about. So there are a lot of metabolites of curcumin, and some of them are completely inactive, while others are even more active than the parent. So, for example, if you give curcumin orally, it undergoes glucuronidation and sulfation. And those two metabolites are completely inactive in our hands, and we have recently synthesized them and found that even synthetic had no effect. However, curcumin also undergoes reduction if it is given orally, and that's what becomes a white curcumin. And that curcumin, as for activation of AMPK, as you know, one of the AMPK is very closely involved in diabetes. And now it is done, and metformin is used to activate that particular enzyme. And metformin now is also used for now cancer that it is being explored. So because the glucose metabolism in the tumor is also very, very abnormal. So turn out that curcumin is about 400 times more active than metformin, number one. And number two, curcumin metabolite is 100,000 times more active on molar basis as compared to metformin. So there are metabolites which are more active as compared to the other ones.
First of all, thanks for this very interesting talk. My question is, curcumin is recently used as a photosensitizer and in photodynamic therapy. And as you know, this is produced through single oxygen production or free radical. My question is, what about the other mechanism? It will proceed with the same modality without light, or there is another way of interaction that by all means, by the end of the day, will get good results relating cancer treatment.
Yeah. So I think, again, I have to repeat that the more we know, I feel lesser we know. Why? Because there are so many targets and so many mechanisms. Curcumin as an antioxidant, it is turning out to be it is 50 times more potent on the molar basis as compared to vitamin E or vitamin C. And yet, most of the anti-inflammatory effects that I showed you is working through the pro-oxidant methods, okay, not through the antioxidant. Number two, that we also put together, I mentioned 12 different cell signaling pathways and asked the question that is curcumin affecting any of them. We have yet not found a cell signaling pathway that is linked to cancer and not affected by it. Okay. So it is multi-targeted, but what is mind-boggling that how a single molecule can do all that what I just mentioned you, and that is still, we don't fully understand.
I have two questions, please. Should we all start taking curcumin or anti-inflammatories every day from now on? And the second one is, how do you envision these inhibitors of inflammation, NF-kappa B inhibitors, as sensitizers or as more curative? So should we use them as, again, as a complement to establish chemotherapy or established drugs that are being used today in therapy, or just as an additive to make other drugs be more efficient?
So the question is that what kind of setting, so as to speak of, we can use? Is it preventive, is it therapeutic, is it both? And whether it is preventive or it is therapeutic, the molecular targets are the same. We are the scientists. So we know that there are cell signaling pathways that are involved in prevention. There are same cell signaling pathways that are involved in treatment. So, but simply the stage of the disease is different. In one case, maybe the disease is indolent or it's not there at all. In the other case, we know that the disease is there, and so we have to do something. So my answer to you is it depends on the state of the disease. If there's no disease at all, one can use it as a preventive measure. But if there is clearly a disease that right is sitting in front of us, one can use it alone, and if needed, use it in combination with the existing state of threat. And I can tell you that when I mentioned that it takes 20 to 30 years for cancer to develop, and if somebody is diagnosed with cancer, the doctor immediately will start the chemotherapy, and he wants you to undergo chemotherapy right away. Question is, what is the rush? It did not happen overnight. So what is going to make a difference if you can wait for a day or two or a week or a month, or a few months, before you undergo chemo? And we have a lot of patients who have done just that. That even though the doctor wanted them to undergo chemo immediately, that they started taking curcumin for a month or two or three, they went back to the same doctor. Doctor said, "We don't have a cancer anymore." I mean, so they continue to take curcumin and they make the disease totally indolent. So it is that kind of proof of the concept that you do not have to use, in combination with chemo. But if needed, you can use in combination, because virtually there are 300 reports published that curcumin is very, very synergistic with virtually all the chemos and radiation.
Should we take every day now curcumin?
Why not? So, I mean, I've been, to be honest with you, I've been taking it for last 15 years, 500 milligrams, one capsule a day keeps the doctor away. I don't remember when I went to the doctor last time.
Professor Scott, sorry, there are a lot of people waiting who want to ask questions.
Thank you for your excellent presentation. I have two questions. One is about the origin of curcumin. Is the synthetic one or the natural curcumin? And the second one is, what is your opinion about Mediterranean diet and the olive oil?
So, synthetic or natural? So, in principle, it should not matter. And we have to be sure that what other contaminants, if any, are there, are chemical. And you can get a natural which When I started my research, it was $20 a kilo. Now it is $200 a kilo. I can get the synthetic for $20 a kilo. So it is just a cost thing. So in principle, it should not matter whether it is a natural or it is synthetic.
So the next question, please.
Okay, I have two questions to you. First question about dosages in different diseases. Are there really needed these different dosages? And second question, what about the combination between curcumin and piperine as metabolic inhibitor?
See, we are scientists, which means we want evidence, we want some kind of rationale, some kind of logistic. So apparently, what we've been thinking, I get asked a lot, by people that what kind of dose that they should be using, just what you mentioned. And truly speaking, we really don't. As you saw from the reason I wanted to show you all the clinical trials, the dose ranges anywhere from 30 milligram to what I did not show you, Dean Brenner in University of Michigan, he has gone as high as 20 grams a day for 3 months just to find a toxic dose, and he could not come up with it. And that's a good news, that there's no toxic dose. So why should you be taking more than necessary? So the only reason I mentioned that I take 500 milligram because that is the simplest capsule that is available, and most of the companies make that size capsule, and there is no other reason. So I think that everything is very, very arbitrary, and we are in the process of designing a chip that I mentioned you that 500 genes, you put all that in one chip, you put it in your mouth. If it turns red, too much inflammation. If it turns green, your inflammation is up. Because all these inflammatory cytokines, they are present in saliva and they are present in the urine. So you can, in a very non-invasive way, determine yourself that do I have too much inflammation, and then adjust the dose accordingly. And that is the ideal situation. So if you don't have to take metformin or any of the other drugs or even statins for that matter, curcumin will inhibit HMG-CoA and will act like statins. So you don't have to use any of those. And there's no known toxicity. So even statins, that there are a lot of toxicity. We just recently had a workshop at NIH that which was basically the whole workshop was on inflammation and its role in chronic diseases. And they put down steroids, they put down aspirin, they put down statins, they put down metformin as a potential anti-inflammatory agent. Question is what else? So I was invited for what else? And I outlined that all those 4 agents, that what I just described you, that people are taking, have a lot of side effects and the cost issue and so forth. But here you have all these things like curcumin, and there's so many others. Initially the question was also asked about the Mediterranean diet and and olive and so forth. And again, the same philosophy applies over there, but simply we want evidence. We want clinical trials. So without clinical trials, we cannot say anything. And these are dietary agents, so we should not be asking mice that, how much curcumin do you like, or how much turmeric do you like, I mean, these are dietary agents people have been eating for thousands of years. If mice was a good model, everything that works in mice should work in humans, but we know they don't. So we might as well try directly in people and see if it is doing what it is supposed to do.
So we have time for one more question, Professor Hindu, and then the rest of the people, we will have a coffee break, so you can leave Bharat, and I think he will be available for questions. So let's go to have some coffee after Professor Hindu question, and then please feel free to ask Bharat.
Yes, thank you very much. I would like to congratulate you for your excellent presentation. I'm surprised as a pharmacochemist, especially with the preclinical data, but a bit disappointed as a representative of European Medicines Agency, where I don't know if you are informed, but 1 year before, curcuma longa has been assessed and it was approved, at least in European Union countries, just with a very light indication. only against mild gastrointestinal disorders. And as a matter of fact, because at EMA, I'm also doing a part of work there as vice chair of that committee, we have seen that, especially at acute toxicity data, and also even genotoxic data about curcumin, were somehow risky. And that's why it was taken a decision of such indication. And my question is, what is the legislation at the States, in USA, and how somebody can find either the extract of curcuma or just curcumin? Because in Europe, by the legislation, it's not easy to find things on the market, especially with such indication, prevention of cancer, or even as adjuvant against cancer therapy. So I say that as a phytochemist, I love preclinical data, but we need a regulatory area. I'm not coming from a regulatory area, I'm academic, but especially in Europe, it's not so easy to treat cancer or to say something for prevention of cancer. I know that FDA is maybe lighter the situation. That's why I would like to ask you this. Under which legislation curcumin can be found in the United States? Thank you.
So I think, FDA have done their own toxicology on curcumin. And they have published a 300-page report on what curcumin does. And as far as they are concerned, it is grass. Grass means generally regarded as safe. So they have no concern. So a lot of companies in the US, they have been using it as for cereal, they have been using it for cheese, they have been using it in butter, and they are using it as a coloring agent. Okay.
But in special doses. So what is the maximum daily dose? Because we are talking about drug somehow.
Yeah. So I think that as for maximum daily dose, I don't think that anybody really knows that what is maximum daily dose, because it all depends on the lifestyle. And again, remember that we are living in an era of personalized medicine, which means that you cannot use that the dose which is applicable to person X, use it on Y. So you have to determine for yourself that what is a good dose for you, and that's what personalized medicine is all about. That you cannot have somebody recommend you that, okay, this is the dose only for you and nothing else. So that kind of data simply does not exist as far as I know.